Hey guys, it's been a while. We can finally start doing things for astronomy again, though. So we're going to go ahead and start with the planets in the solar system, which is where we would have been if we'd been in school. Like 2 weeks ago, we would have started your presentations, which I'm really sorry that I'm missing. So instead, what we're going to do is I will just do a quick run through of the terrestrial planets this week, excluding Earth, of course, because we already did Earth. And then next week, I'll do a quick run through of the Jovian planets. So instead of spending like 2-3 weeks on the planets and each planet getting its own day with your presentations, I'm just going to do a quick run through of them. So we will start with the terrestrial planets. The terrestrial planets, so these are these four guys right here. We have Mercury, Venus, Earth, and Mars. Earth, we've already talked about. The Earth got its own units, so I won't be mentioning Earth very much here except for comparisons. The terrestrial planets are called that because they are rocky. So they are rocky and metal rich. Unlike the Jovian planets, the gas and ice giants, which are gas and ice rich. The terrestrial planets are rock and metal rich. And because of that, they are smaller, they are denser, and they are closer to the sun than the Jovian planets. So the Jovian planets start with Jupiter, which comes after the asteroid belt. These are the first 4 planets from the sun. So they're much closer, they're much smaller, and they're much denser. Let's start with the first one, Mercury. So this is an actual picture of Mercury. It should remind you of something. It should remind you of the moon, hopefully. Basics about Mercury, its average distance from the sun is 58 million-ish kilometers. This specific number isn't important, but I put it there because I want you to think about the fact that Mercury has the most elliptical orbit in our solar system. So what that means is, even though on average it's 58 million kilometers, when it gets closest, it's 47 million kilometers away from the sun. That's actually really, really close, even though it's a gigantic number. And when it's farthest away, it gets as far as 70 million kilometers. This difference is huge, and it's the largest of any planet in our solar system. So when we say most elliptical, we're saying Mercury's orbit looks the most like this. This is an exaggeration, this is just a depiction, but Mercury has the most stretched out, most oval-looking orbit of all the planets in our solar system. Mercury also has a length of its day of 58.63 Earth days. So it rotates pretty slowly. It takes 58 days here on Earth for Mercury to rotate once. But its year only takes 88 Earth days. So Mercury's day is 2/3 as long as its year. And that 2/3 relationship is actually really significant. So if you were to, let's say, stand somewhere in Mercury, and you were to just stand there for as long as it took to see one whole day happen, you wanted to see the sun rise and set again. Well, it would actually take you a really long time to see the sun rise and set again. So the reason this happens is because of this weird 2/3 relationship. So if you're standing somewhere in Mercury, you see the sun rise, and eventually you'll see the sun stop and starts to go backwards. And then after it starts to go backwards for a bit, it will then resume going back normal and finally set again. And you'll find that it took you about 2 Mercury years to see one whole day on Mercury, to see one whole sunrise, sunset sequence. Mercury is kind of a weird planet because of this weird 2/3 relationship, but nature is apparently perfectly happy to have that. Here is our moon. So you can see our moon has a diameter of about 3,476 kilometers, and Mercury is only 4,888 kilometers. So Mercury isn't much bigger than our moon. So Mercury is a fairly puny planet. There are moons in the solar system that are larger than Mercury. They just belong to Jupiter. Does Mercury have any moons? No. For several reasons. Number one, Mercury is kind of small. If it had any moons, they'd probably be like little potato things. But also, it's right next to the sun. So the sun has such strong gravitational pull that anything Mercury tried to hold on to, the sun could hold on to way better, and it would just take them. Its tilt is about 2 degrees, so Mercury is pretty much straight up and down. And it does have a magnetic field. There are some planets in our solar system that don't have magnetic fields. Mercury's temperature. It's right next to the sun, so you'd expect it to be pretty hot, and it is during the day. But Mercury doesn't have an atmosphere really, so it can't hold in heat. So once it becomes nighttime, Mercury goes from having a temperature of 430 degrees Celsius to having a temperature of negative 180 degrees Celsius. This huge difference is caused by the fact that it has no atmosphere. Can't hold in heat, so once the sun stops shining on you, it gets really cold. Similar things happen on the moon. So, I just showed you Mercury is 430 degrees Celsius during the day. Is Mercury the hottest planet in the solar system? No. That is someone else that we'll talk about. I mentioned that Mercury does have a magnetic field, but it's super weak. 1% the strength of Earth's magnetic field, but it's there. So Mercury gets to claim something. And we believe it is caused by an internal dynamo effect, so the idea of a spinning molten core that produces a magnetic field, we think. And we believe it used to be stronger in the past. That is connected to the fact that Mercury has a core that takes up 75% of its radius. So Mercury has an abnormally large core. And we think this is because something really big hit Mercury. Remember, I told you guys that this idea that something hit it is going to be used a lot when we aren't quite sure what caused it. We think something hit Mercury, and that knocked a bunch of pieces off of Mercury, knocked away crust and mantle. So you have this big core, and suddenly you've lost the outside materials. And now the outside materials just have to shrink to fit around this really big core that's been left over. So you have a core that's too big for the rest of the planet. And that shrinkage that I mentioned is going to come up later. Mercury's atmosphere, there's something there. There isn't no gas. The problem is there's so little of it. There are very few elements just kind of hanging around the outside of Mercury. Its gravity is holding on to something, but it's more of an exosphere, and that just means really thin, faraway gas being held on by a planet. So not a true multi-layered thick atmosphere like Venus or Earth, but it does have something. So those that shrinkage, the fact that the Mercury got hit by something in the past that I mentioned. So Mercury is clearly bearing the marks of lots and lots of impacts, just like the moon. So this picture is being brought back again to show you, hey, it's covered in marks, and that's just like the moon. These largely dictate the surface features that you're going to see on Mercury. So rupes are the remnants of that shrinkage I referenced. So Mercury, we believe, used to be bigger, and chunks of it got blown away when something hit it. Well, then the planet was left needing to put itself back together. So that outside crust kind of had to shrink to fit around this big core. And when it did, it created these ripples. So these ripples are actually leftover marks from when Mercury had to shrink its crust back onto itself. So this crust had to shrink, and you're left with these wrinkles. And these wrinkles can be quite tall. They can be over 1 mile tall and hundreds of miles long. But all they are remnants of the fact that we believe its crust shrank. So they're just ridges. They're produced when the crust shrank. And they can be very, very tall. Hard to tell from this picture, but this thing right here is hundreds of miles long and about 1 mile tall. And you can see these large craters. Speaking of craters, Mercury has the largest crater in the entire solar system. Caloris Basin, so this whole thing right here. So this is about 1,300 kilometers in diameter. Largest crater in the entire solar system. Studying Mercury is kind of difficult because Mercury is small and fast. So it's hard to observe from Earth because it's so small, it's fast, it's really close to the sun. So since it's close to the sun, it follows very quickly behind that sun. So here's sunset, so you can see the sun is down here in the corner. Mercury is following right after it. So when the sun sets, Mercury follows. When the sun rises, Mercury follows. So if you want to see Mercury, you need to be looking nearish the horizon around sunset and sunrise. So too close to the sun, small, and fast. Venus. So Venus is about twice as far away from the sun as Mercury. It's about 108 kilometers instead of 57, or 108 million kilometers, sorry. And unlike Mercury, which had the most elliptical orbit, Venus has the most circular orbit of all the planets. So Venus has the orbit that is most shaped like a circle. Now, just like Mercury had a weird day-year thing going on, Venus also has a strange day-year thing. So if you wanted to see how long it took for a sunrise sunset cycle on Venus, so you wanted to see how long a whole day was, well, you would actually have to wait longer than a whole year on Venus. The length of Venus's day is 243 Earth days. So you need to wait 243 Earth days for one whole day on Venus, while its year is only about 225 Earth days. A day on Venus takes longer than a year on Venus. This is very unique in the solar system. So this is clearly something I would ask you on a quiz. Venus's diameter, about 95% of the Earth's, and its mass is about 82% of the Earth's. Fairly close. It's the closest in the entire solar system, so it's often referred to as Earth's sister planet, or evil twin. And we'll get to why it would be evil as opposed to just twin. Venus's tilt. So the Earth's tilt is about 23.5 degrees. It's got a nice tilt that gives us our 4 seasons. Venus, on the other hand, is a tilt of about almost 180 degrees, meaning it's almost perfectly upside down. So this upside down tilt of its axis is why we say Venus rotates in the opposite direction of all the other planets. And it also has no moons. Venus's magnetic field, it doesn't have one, at least not the way the Earth does. So it doesn't have an internally generated magnetic field. The Earth has its spinning metal core, and that produces a magnetic field that encompasses the entire planet. Venus does not. And we believe it's because it rotates so slowly. It rotates so slow that a day takes over an entire year on that planet. And since it rotates so slowly, it can't produce its own magnetic field the way ours does. But Venus's atmosphere is so thick that as solar radiation hits its atmosphere, it actually produces a weak magnetic field of sorts. It's not the same as the Earth's magnetic field. It's not as strong. It's not produced the same way, but there is something there. Speaking of its atmosphere, Venus's atmosphere is super thick, super dense. If you were to stand on the surface of Venus, it would be like standing a kilometer under the surface of our ocean. It is so thick that it could crush things on its surface. It's also almost 97% carbon dioxide. You can't breathe this. You can't breathe it. It's going to try to crush you. Venus is not a fantastic place. Super thick atmosphere, mostly carbon dioxide. And it's so thick that sunlight hitting the surface or hitting the planet, most of it gets reflected. That's why Venus usually appears a bright white color, because most of the sunlight hitting the planet just gets reflected away. And this actually makes Venus the brightest object in the night sky besides the moon. So here's a picture of the moon. Here's a picture of Venus. It's incredibly bright in the sky. Chances are you've seen it before and just thought it was a really bright star. But it was most likely Venus. It's the second brightest thing in the night sky. So Venus is actually the hottest planet in the solar system. I mentioned earlier that Mercury is not, Venus is. And the reason for that is Venus's thick atmosphere traps all of its heat. So Venus's temperature just kept rising because of this greenhouse effect happening with its atmosphere, and Venus's temperature doesn't really drop. So nighttime on Venus doesn't get much colder because it holds in all of its heat. The average temperature on Venus is 462 degrees Celsius, 864 degrees Fahrenheit. This temperature, this is high enough to sterilize things. So this temperature is used on Earth to sterilize materials. So you can imagine there's probably not much life on Venus, considering this is above the temperature needed for sterilization. And this high temperature is because of Venus's carbon dioxide-rich atmosphere. So the surface of Venus, since it's so hot, you can imagine it's very dry. It's actually covered in lots of volcanoes. We don't believe they're active, but there's over 1,000 very wide, flat volcanoes, often called pancake domes. You can see this picture, it looks like there's just two pancakes hanging out on the ground. But these are huge. This thing is at least 40 miles wide, but they're not very tall. Sometimes they're less than half a mile tall. Volcanoes on Earth are quite different, but on Venus, it's largely due to the atmosphere. So we believe lava would kind of just ooze out of them as opposed to being shot up in the air. So ooze out and just create this large, flat surface. We do think Venus probably had oceans in the past. The thing is, though, as Venus's temperature increased, the oceans would evaporate. And as they began to evaporate, it released water vapor in the air. Water vapor is really good at holding heat. So as water vapor goes in the atmosphere, it holds in heat. If it's holding in heat, then it's going to get hotter on the planet. If it's hotter on the planet, then more water evaporates. You get more of this stuff. It creates this self-feeding cycle. And this cycle is going to make the temperature go higher and higher and higher. This is what the danger of climate change is. As the temperature increases, eventually, there's nothing you can do to stop it. It doesn't need your help anymore to raise the temperature. It can do it all on its own. So hopefully, Venus is not a look into our future. We have a lot more water than Venus most likely ever did. So our version of this would probably be a lot hotter. And our last terrestrial planet, Mars. Very distinctive looking because it's so red. So average distance from the sun, over twice as far as Venus is. Comparing it to Earth, it's only 11% of the Earth's mass and about 53% of Earth's diameter. Mars is a lot smaller than the Earth. Gravity on Mars is only about 38% of the strength of gravity on Earth. So it'd be very easy to run and jump around, similar to how it was on the moon. It's stronger than that, but it's still weaker than it is on Earth. Mars's tilt, very similar to the Earth. Earth is about 23.5, Mars 25-ish degrees. So this means Mars would experience seasons the way we do. The length of a day on Mars is also very similar, 24 hours, 39 minutes. So it'd be a pretty easy transition to people living on Mars. Difference comes in the year, though. The length of a year on Mars is 687 days, so about twice as long. This also means that our seasons on Mars would be twice as long, even if they are similar to Earth. Mars does not have an internally generated magnetic field. We don't think it has a molten core. Clearly, it spins fast enough. It's got the same-ish length of day as the Earth, but we don't think it has a molten core, and that would explain why it doesn't have a magnetic field the way the Earth does. Its atmosphere is very thin. So Venus, super thick atmosphere. Mars, very thin atmosphere. Still mostly carbon dioxide, though, so still not fantastic for breathing. And because the atmosphere is so thin, the planet doesn't hold in heat very well. So the average temperature of Venus was, 460 degrees Celsius. On Mars, it's negative 63 degrees Celsius. So Mars, on average, is much colder. But if you look at those temperatures, this isn't too bad. Like, there are temperatures colder than this on Earth. Now, granted, this is the average. It does get much colder, and it could get warmer. Our rovers on Mars have regularly reported temperatures above freezing on Mars. So Mars doesn't seem terrible for humans to go hang out at. But while the temperature isn't that bad, Mars does get covered in global dust storms. So here on the right in this animation is Mars normally. On the left is Mars undergoing one of its global dust storms. These can be quite devastating. So if we were to have some kind of colony on Mars, we would definitely need a way to cope with these. In fact, one of our rovers, the Opportunity rover, a recent dust storm actually ended its mission. So they knew the dust storm was coming and put it in a low power mode. And after the storm, they tried to reactivate it, but they believe that its solar panels were covered in too much dust and it just doesn't get enough power to turn itself back on. So it's been declared lost. So poor Opportunity was killed in a dust storm. Mars has two moons, Phobos and Deimos. They are both these crappy potato-looking things right here. So they're very small. One of them, Deimos, orbits really far away from Mars. Phobos, on the other hand, orbits a little too close to Mars. So Phobos is likely going to crash into Mars at some point, if not crash or be torn apart. So Phobos is going to be destroyed soonish, and by that I mean probably thousands of years. Deimos, on the other hand, might get flung away. So Mars may end up in the future having no moons. And Mars does have a couple very important surface features. There's Valles Marineris, which is the largest canyon in the entire solar system. I took this picture from CrashCourse. Hopefully YouTube and CrashCourse won't mind. I do have their watermark down here. Thank you, CrashCourse. So here is the Grand Canyon. This whole thing is Valles Marineris. So as you can see, much, much, much larger than even the Grand Canyon, the largest canyon on Earth. And this is Olympus Mons, the largest volcano in the solar system. So this dwarfs Mount Everest. It's absolutely huge, but it is believed to be extinct now, so no longer active. So those are the things that you need to know about the terrestrial planets. So go through this video, go over these things. Anything that's in this video is fair game for a quiz about the terrestrial planets. If you have other questions, please email me. Please leave questions on Google Classroom. You can put them in the YouTube comments. I'll be posting a video at least once a week. Be sure to like and subscribe, and I will see you guys later.